Let's see if we can write down the general term of this series. So we have 3 plus 6 plus 12, our geometric series. The general term of a geometric series, it is given by Tn is equals to AR to the power n minus 1. A is the first term. The first term in our case is 3. R is T2 divided by T1 or T3 divided by T2. We just divide the two terms that are next to each other. So here, if we divide T2 by T1, we're going to have 6 divided by 3, which is equals to 2. So we have A, we have R. Tn will be equals to A, which is 3, R, which is equals to 2, to the power n minus 1. So this is the general term of this series. Let's move to 3.1.2. So in 3.1.2, we're supposed to calculate the value of k such that this sum is equals to 98,301. Okay, let's go ahead and find the terms of our series. So the first term, T1, will be equals to 3 divided by 2 to the power p. P is starting at 1, right? So when p is equals to 1, we're going to have 2 divided by 2, so t1 is equals to 3. And then t2, we're going to have 3 divided by 2, and then 2 to the power 2. To the power 2 is 4, so we're going to have 4 multiplied by 3, which is 12. 12 divided by 2 is 6, so that is t2. And then t3 is equals to 3 divided by 2, 2 to the power 3. 2 to the power 3 is 8, so we have 8 multiplied by 3, 8, 16, 24. So we have 24 divided by 2, which is equals to 12. So it seems like we just have 3 plus 6 plus 9. We're supposed to find the value of k, for which this sum is equals to 98,301. How can we possibly do that? We have a formula for the sum of a geometric series, while a finite and an infinite. In our case, we're going to have the sum being equals to a multiplied by r to the power n minus 1 divided by r minus 1. You cannot use sum to infinity is equals to a divided by 1 minus r in this case, because r is not between minus 1 and 1. Okay, so what is the value of n for which we're going to have a sum of 98,301? Let's find out. A is the first term, which is 3. R is the common ratio, which is 2. So 2 to the power n minus 1, everything divided by r minus 1. So that is 2 minus 1, which is just 1. Okay, so we're going to have 2 to the power n minus 1 being equals to 98,301 divided by 3. Okay, let me put that in my calculator real quick. I'm getting 2 to the power n minus 1 being equals to 32,767. If I take minus 1 to the right hand side, I'm going to get 2 to the power n being equals to 32,768. I don't know whether I can write this number with a base of 2 or not, but it is just going to waste my time trying to figure that out. I'm just going to go ahead and take log on both sides. If I do that, I'm going to get n log of 2 being equals to log of 32,768. So I can just divide both sides by log of 2, right? So 32,768, everything divided by log of 2. So let me go ahead and put that in my calculator and see what I have. So 32,768 divided by log of 2. So n is equals to 15. The value of k is supposed to be equals to 15, such that we have a sum of 98,301. N is equals to k minus p plus 1. N is 15. K, P is 1 plus 1. So it's easy to see that 15 is equals to K. Right, so that is 3.1.2. Let's go ahead and do the last question, 3.2. So in 3.2, let's hear the stories. A geometric sequence and an arithmetic sequence have the same first term. Okay, so let's have arithmetic and have geometric. Okay, they have the same first term. So we have A and A. T1 is equals to A. This A is the same, right? And then the common ratio of the geometric series is 1 divided by 3. So common ratio R is equals to 1 divided by 3. And then the difference on the arithmetic is equals to 3. And then the stories carry on. The sum of 22 terms of the arithmetic sequence is 734, more than the sum to infinity of the geometric sequence. Okay, let's make sense of that mathematically. The sum of the 22 terms of an arithmetic sequence is 734, more than the sum to infinity of the geometric. So, okay, S22 should be equals to S infinity plus 734. That is how I'm interpreting the question. Okay, but what is sum on an arithmetic series or sequence, whatsoever we're dealing with here? We have n divided by 2 multiplied by 2a plus n minus 1 multiplied by d. And then the sum to infinity is a divided by 1 minus r plus 734. Okay, let's go ahead and substitute. N is equals to 22. So we're going to have 22 divided by 2 multiplied by 2a. So we have 2a is a. That's what we're interested in actually. And then plus n minus 1. So 22 minus 1 multiplied by d, which is 3. Okay. This is equals to a divided by 1 minus 1 divided by 3 plus 734. Okay, we have to solve this now. So we're going to have 11 multiplied by 2a. Then 22 minus 1 is 21. So we're going to have 21 multiplied by 3. Is that 63? Okay, so we have plus 63 minus... Okay, no, that's it. 21 multiplied by 3. 2a plus 63. This is equals to a divided by... What is 1 minus 1 divided by 3? That is 2 divided by 3. Okay, so if we say 1 divided by 2 divided by 3, we're going to get, instead of writing a there, let's instead write 3 divided by 2a plus 734. Okay, let's multiply out on the left hand side. We're going to get 22a plus 63 multiplied by 11. That is 693, being equals to 3 divided by 2a plus 734. Let's take the a's to the left hand side and the constants to the right hand side. Okay, the a's to the left. So we have 22a minus 3 divided by 2a being equals to 734 minus 693. So what is 22 minus 3 divided by 2? We have 41 divided by 2a being equals to 734 minus 693, which is 41. Okay, so a is equals to, I have 41 divided by 41 divided by 2. A is equals to 2. Did you get the same answer? Just let me know in the comments.